Hi folks, this is Kareem Raouf for IT Visualizer channel. We will continue our lab, the matrix lab, the video number 120. We have been discussing in the previous video the following. We are still working with troubleshooting Windows using remote tools like Command Shell and PowerShell. Uh, we have seen the different ways that we try to explain this topic through. For example, we have asked a Claude 3.5 Sonnet to explain this topic using three different methods. The first method is to ask it directly to explain it in simple terms, like I am a junior IT. And the second way is to explain it using hand-on exercises. And the third way is to explain it through a learning dialogue. And we have explained one case in the previous video. Today we will discuss a second case, how we can use remote tools to solve problems concerning the Windows. Okay, so let's see the second case generated by Claude 3.5 Sonnet. And actually I like the creativity of Claude 3.5 Sonnet. I think it's the best AI tool in the area of creativity. It creates very good and creative answers. Let's try to read the second case, and the second case will be security investigation. So the tools will be used, or remote tools will be used to investigate a security issue. So let's read the case out loudly and see how we can uh, use remote tools to explain uh, something related to security. Let's read it out loudly. Scene 5, and then scene 6, and then here you go. This is the last line, and at every case it gives you a virtual lab setup for how you can do this case in a virtual environment. So let's try to read out this loudly and see what it contains.
Scene 7. Virtual lab setup for security monitoring. Mia. This whole The case of the mysterious network traffic. Scene 1. The Hook security alert. 9:30 a.m. Wednesday morning. Mia is reviewing system updates when an alert pops up on her screen. Mia, frowning at her monitor. That's odd. She picks up her phone and dials Victor. Victor, answering promptly. Victor speaking. Mia, morning, Victor. I just got an alert from the security monitoring system. It's showing unusual network traffic coming from one of our application servers. App, SRV03. High volume of outbound connections to unknown IP addresses. Victor, voice becoming serious. That doesn't sound good. Have you checked the security dashboard for more details? Mia, scrolling through screens? Yes, but it's only showing summary data. 20 times normal traffic volume, starting about 3 hours ago. Could be malware, could be a legitimate process gone wild. I can't tell from these graphs. Victor, thoughtfully, this is a good chance to show you how command line tools can help with security investigations. Meet me in the security room in 10 minutes. 10 minutes later, in the Security Operations Center. Victor, settling into his chair. So, we have unusual outbound traffic from app, SRV03. Let's investigate this systematically using command line tools. They'll give us deeper insights than the GUI monitoring tools. Mia, eager to learn. Where do we start? Victor, first, let's confirm connectivity and check basic system status. Then we'll dig into network connections, processes, and finally look at any suspicious activity in the logs. Victor opens a command prompt window and begins typing. Copy. Ping app, SRV03. Output shows successful pings. Victor, good. The server is responding. Now, let's establish a remote session and begin our investigation. Scene 2. The Foundation Network Diagnostics. Victor, command line tools are perfect for network investigations. Let's start by examining the current network connections on the server. Copy. Winners are app, SRV03 netstat, Ono Finster established. The output shows dozens of outbound connections to various IP addresses on port 443. Mia, studying the output. That's a lot of connections. What does the ONO parameter do? Victor, good question. In netstat, a shows all connections and displays addresses and ports numerically and shows the process ID associated with each connection. The pipe to Feinster filters for established connections only. Mia, pointing at the screen, look at all these processes with ID 3456. They're all connecting to different external addresses. Victor, let's find out what process that is. Copy. Winners are app, SRV03, task list Feinster 3456. Output shows. Copy. Java.exe 3456 console 1 256,432K. Mia, Java process. Our inventory application runs on Java. Could be compromised? Victor, possibly. Let's dig deeper to see when this process started and what command line parameters it's using. Copy. Winners are app, SRV03 MIC process where process ID equals 3456 get command line, creation date. Output shows the full command line and a creation timestamp from early morning. Victor, now let's check if this is a known, scheduled application or something that shouldn't be there. We can use tasks to check the scheduled tasks. Copy. Winners are app, SRV03 stas/query/FO list Feinster/iJava. Output shows a scheduled inventory sync task that runs daily at 6 a.m. Mia, so it's a scheduled task, but why is it generating so much traffic? Scene 3. The challenge escalation, investigating files and logs. Victor, let's check when the Java executable was last modified. Copy. Winners are app, SRV03 dir c:\program whitespace files \inventory app \bin /javaw exe/a. Output shows the file was modified yesterday evening, much more recent than the application's installation date. Mia, alarm, that's suspicious. The file shouldn't have been modified recently. Victor, agreed. Let's examine if any other files in that directory have been recently modified. Copy. Winners are app, SRV03 PowerShell, command get child item, c:\program files \inventory app, recurse where object, $insert, the last write time, gt, get date, add days, -2, select object full name, last write time, sort object, last write time. Output shows several JR files and a configuration file were modified yesterday. Victor, now we're getting somewhere. Let's check what user made these changes by examining the security event log.
So we can see here, this is a security investigation script. Here he is suspecting that someone has played with the Java components. This is a script. I think this is using batch scripting. Security investigation script. REM investigates suspicious activity on a server by analyzing logs, processes, and file modifications created by Victor and Mia. Here you put the server name and then enter the days you want to look back in the I think in the event viewer, and then which logs he will investigate. I don't see here what days he will or where he will get it, so let's try to move along with the script to see. Now he is getting current network connections, collecting current network connection, the IP address of the network on the server, get processes with command line, getting the processes running on the server, collecting recent modified files, but which recent modified files in C programs, C Windows 3032. So here he is suspecting someone has played something in the program files. Okay, maybe He's trying to see if someone has played with the operating system files, program files, but he didn't put the Java here. I think we need to add the Java here. And again, seeing schedule tasks on the server. I think all of these he have listed them before, but he's combining them in one script. So he need to see the schedule tasks. And then the last one is to collect security events. He will go and see the security events. I think from 2 days ago or something, and he will see certain events. I think all of these are related to creating users, creating groups, creating all of these are events. I think that is related to modifying or adding new accounts, removing accounts, playing with group policy objects maybe. So all of these are events he will analyze. We will read, I think I will read here what this script will do exactly. Collect login, so he's collecting security event logs. Someone has added something, users or groups, and then we have the login events, who has logged in to the machine. I think this is also a couple of events. I think maybe event, there is a certain event that is related to this one, login. So he will try to get event 4624. I think this is login into the server, and he will see the login type. So here he is seeing if it is an interactive login or a remote session. Okay, this is also one good thing here. Collect system audit events if available. If you have audit concerning also events like 4663, and I think also this is related to changing something in or adding users or groups. Anyway, so all of these are added. Collect installed software if there is any software added, and then generate a summary, and then at the end he will give summary to all of what he has collected. So I think this is a script that will collect a lot of info that is needed to investigate if there is any modification uh, to uh, to some files and investigating the login. So he's saying this suspicious activity on a server, analyzing logs, processes, and file modification. So let's read here after that what he will say concerning this. So we can now read from here.
Victor, I've prepared a security investigation script that will collect key information we need. This will gather network connections, process details, modified files, and relevant event logs. Copy. Security investigation.bat app, SRV032. They wait as the script runs, collecting data about the server. Mia, impressed. That script is comprehensive. How does it help us investigate compared to using GUI tools? Victor, command line investigations have several advantages. We can quickly collect data from multiple sources. The investigation is repeatable and documented. We can analyze the data programmatically. It captures the exact state of the system right now. Mia, looking through the output files, look at this in the login events file. There was a remote login from an external IP address at 2:15 a.m. Victor, good catch. And here in the file access logs, that same account modified the JR file shortly afterward. Let's check who that user is. Copy. Winners are app. SRB03net user Jane Doe. Output shows account details for a contractor whose engagement officially ended last month. Mia, an expired contractor account that's still active. That explains it. Scene 4, guided practice, malware hunting. Victor, now that we've identified the likely attack vector, let's check if there's malware on the system. Command line tools are excellent for this kind of investigation. Mia, what should we look for? Victor, let's start by examining scheduled tasks, registry autoruns, and suspicious processes. I'll guide you through the commands. Copy. Winners are app srv03 stas/query /fo table /v finds /i/v Microsoft Windows. Output shows the inventory task plus a new suspicious task called System Service Manager scheduled to run at system startup. Mia, pointing that System Service Manager task isn't in our documentation.
So here is trying to get any task called Microsoft Windows. Output shows the inventory task plus a new suspicious task called Server or System Service Manager scheduled to run at system startup. So here, why he is searching for Microsoft Windows? How he will know that this is the task that, or why he identified these words as his searching criteria? How he knows that this will be the name of the suspicious schedule task? So saying that now uh, called System Service Manager, he is searching for what? Searching for tasks under Microsoft, under Windows. So he's suspecting. Let me see when I copy this script and try to ask AI tools to explain it, because I think I do not understand this. He is searching for a certain task under Microsoft Windows, or he's searching for a task called Microsoft Windows. Let's ask Grok to explain it. So let's do that and then give this also to ChatGPT and ask it to explain it. So the script connects to a remote server and lists all custom schedule tasks on that server, while leaving out the built-in tasks that came with Windows operating system. Let's break it down. So this is the first one, which is understandable: WinRS and the server, and then schedule task query. Okay, query FO table tells to display the list in a table, says SV/for verbose. Okay, so all of this is understandable. As for this one I am seeking here, uh, find SR. I means ignore whether the text is uppercase or lowercase. V means show me only the lines that do not contain the text I'm looking for. Microsoft Windows is the task it's searching for. So it's searching for a task named Microsoft Windows. So take the list of all tasks and remove any lines that mention. So again, what he's talking about. So this part saying take the list of tasks and remove any lines that mention Microsoft Windows. So he's reversing. That. So what means here that he will remove all, or he will exclude all of the Microsoft Windows tasks. So this will leave us with the custom tasks. Let's see how this will be put together. So this is app retrieves details of all tasks in a table, then it filters them out uh, any task where the phrase so appears in details, like so and so, which often identifies built-in tasks. So he's excluding system tasks, which leave us with the custom tasks. The result will be a list of only the custom or user-created tasks, excluding the default Windows system task. In simple terms, the script shows you all of the tasks on the server that were made by users or admins, and it skips the ones that come with the Windows itself. It's like asking for a list of personal appointments but leaving out the ones your calendar app added automatically. So that's a good thing, but can we modify it to list the newly created tasks which will be a more effective way so here I'm asking him to give me a script to list the recent added tasks, so this will help us more. So maybe the hacker has added or created the list recently, so this can be listed easily, but to exclude the system tasks and leave us with the custom tasks, maybe there is a lot of custom tasks. I need only the recent created tasks, so this will be much simpler for observing. Let me see if he will give us a way to do that. So if I go to uh, ChatGPT, I think he is giving us the same one. See, the same one, and very simple and actually not that good. Let's try to see what he said. So here we go. Let's see what is the answer. Okay, to list the newly created task in a more effective way, we can enhance the original approach by using PowerShell instead of relying solely on stask and find this. The scripts filters built-in task using a search string excluding Microsoft, but this can be imprecise. This is what I'm talking about. A better method is to use PowerShell get schedule task, which provides structured data and allows precise filtering of custom tasks. Okay, here is the command. This get schedule task for task not Microsoft for each so and so get schedule task name. So what this will do exactly, this will connect to the remote server, run PowerShell, filter custom tasks, and then get all the tasks, and then execute task in the Microsoft folder, which typically contains system task. Okay, so we will under Microsoft there is a lot of folders for a lot of tasks. He will exclude them all, so this is good. Then we have gathered detailed information about the task, the name, so and so, display it in table. Why this is more effective? Precision filtering by task path targets system tasks more than accurately than a generic string. So he's focusing upon excluding a path, not by searching by a name. So this is good. Detailed output provides verbose information similar to so and so, so flexibility. The newly created means task reset recent example within the last 30 days. You can modify the where object clause to include a date filter. However, this requires accessing the task registration date, which isn't directly exposed by get schedule task. You need to dig into the XML definition. A simplified approach look like this. Okay. But for simplicity, the command above assumes newly created refers to custom tasks rather than a specific time frame, as no time period was specified. So conclusion. So here, if we need to search, but for simplicity, the command above assumes newly created refers to custom tasks rather than a specific time frame, as no time period was specified. Newly refers to custom task rather than a specific, but here I think this could be a good thing. Let's get this one and try to put it here as administrator, and try to get this one, and then maybe we can do like this and try to make this, for example, 5 days, and then press enter. So here, as you can see, we have these was created get schedule task. So this run, or what this will do here, he will get the date where object is so this created or run. This is another way. So auto reg backup, I know that this this I have already created earlier. So I think he is talking about what was running uh, uh, that what was running in that what was running before in I think this is not like Microsoft. So auto reg backup ready Avera. So I know all of these backup event log, TSU update task, TS task user login. What is TSUV? So I think all of these run in the recent. This is talking about modify with objects. However, this requires accessing task registration isn't opposed. You need to dig into the XML. A simplified approach might look like this one. So let's see the previous one. Get schedule task where object is so and so. Pass is not like Microsoft. For each get so and so task name. So and so principal user. So can get copy, and we can run this like this. And let's first try to remove the WinRS because this is not WinRS. I just try to see. This will get us all of the non-Microsoft. So here we go. This is get schedule task. I think there is a problem here. We need to remove the quota at the end. So this will give us all of the non-Microsoft tasks under Microsoft. So we can do this and do like that. Get schedule task, not Microsoft. So all of these are tasks for Microsoft or non-Microsoft tasks. So as we can see here, a lot of details. If you go further up, so here task name, next runtime, status, last runtime. Okay, I can see that status is ready. So all of these are tasks that are not Microsoft. Okay, he excluded Microsoft tasks or the tasks under the path of Microsoft. So all of these are tasks, but I think the recent ones, or I think this is the run, or this is the tasks that run the last get date 5 days. I think these are the tasks that run. Okay, this can also solve our problem because we need to know what task run recently. So here we can see get date the last 5 days. So I think this is good. This tells me that the last 5 days the auto reg backup runs. So this is a good way to investigate which task ran at what time or at a recent time. I think this is a good one. So we can continue with the scenario.
Documentation. Victor, let's check what it runs. Copy. Winners are app srv03//query/tn system service manager /fo list/v Output shows the task runs a PowerShell script in a temporary directory. Victor, now you try examining the script content. Mia, thinking, I need to use PowerShell's get content command to view the file. Copy. Winners are app, srv03 PowerShell, command get content c:\windows /temp /svc manager, .ps1 single quote. Output shows an obfuscated PowerShell script that contains code to connect to external servers and download additional payloads. Victor, excellent. You found a malware script. Now let's check if it's running. Copy. Winners are app, srv03 task list /svc finds to PowerShell. Output confirms PowerShell is running. Mia, confident now. I want to check what command line was used to start it. Copy. Winners are app, srv03 mic process where name equals PowerShell.exe get processed command line. Output confirms it's running the malicious script. Scene 5. The complexity crucible containment. Victor, now that we've confirmed the compromise, we need to contain it. Let's use the command line to kill the malicious processes, disable the compromised account, block outbound connections temporarily, preserve evidence for forensic analysis. Mia, taking notes. How do we do all that remotely? Victor, watch and learn. First, let's kill the malicious process. Copy. Winners are app, srv03 task kill /f/pid 3456. Confirmation shows the process was terminated. Victor, next, let's disable the scheduled task and the compromised account. Copy. Winners are app, srv03 task /change /tn system service manager /disable winners are app, srv03 net user jando /active. No. Both commands execute successfully. Victor, now let's block outbound connections temporarily using the Windows firewall. Copy. Winners are app, srv03 net add firewall add rule name equals emergency block outbound dr equals out action equals block enable equals yes. Firewall rule is added successfully. Mia, won't that disrupt legitimate services? Victor, yes, but it's a temporary measure to stop data exfiltration while we clean up. Next, we need to preserve evidence. Let's create a forensic copy of the malicious files. Copy. Winners are app, srv03 PowerShell command copy item c:\windows /temp /svc manager .ps1 single quote c:\evidence /svc manager .ps1 evidence single quote semicolon copy item c:\program files /inventory app /bin /java.exe c:\evidence /javaw.exe evidence single quote. Victor, now you try creating a memory dump of the remaining suspicious processes for later analysis. Mia, thinking carefully, I'll use proc dump from sysinternals. Copy. Winners are app, srv03 c:\tools /proc dump.exe Majava.exe c:\evidence /javaw.dmp. The command executes, creating a memory dump file. Victor, excellent work. Now we've contained the immediate threat and preserved evidence for further investigation. Scene 6. The integration, remediation, and protection. 1 hour later, after they've completed initial containment. Victor, now that we've stopped the attack, we need to develop a remediation plan. Let's use what we've learned to create a cleanup script and implement better monitoring. Mia, eager to contribute. I have some ideas for that. We should replace the compromised files, implement proper auditing, set up alerts for after-hours logins, scan all servers for similar compromises. Victor, excellent plan. Let's start with a cleanup script.
So this is the cleanup script. This is the server name. removing malicious schedule task. He will remove the system service manager from other servers. So we give him the server and he will search for tasks with this name on the server, and then he will remove it, and then he will I think he will put it in maybe this is in a CSV file. Let's okay, removing the task, then delete the malicious files. So he has already identified the script location. Okay, checking for other suspicious scripts in the same so in the temp he know that this is the script. I think from the task he got the location of the malicious PowerShell script, and then he will search for other scripts, all PS1 in the temp folder, and he will remove them. Restore original application from the backup. Here this is to copy the java.exe uh, that is the original one and replace it. So we all know that the Java infected file is in this location. He will copy or he will retrieve from the backup all of the contents of this folder and replace it with the already used files, okay, or the currently used files. He will replace them from the backup location. Okay, then reset application configuration, resetting the app, resetting app configuration. This is also through a file. He will copy it from the backup to the originally used file or the currently used file. So this is good. Okay, this is on the application server. Okay, I think it will be used only on this or on the app server, not on all of the servers. Then configure auditing. He will configure I think this is the local security policy. He will open audit, object access, account login management. So I think this can be done using group policy if it is in a domain, not to use the local group policy. Then implement PowerShell scripting execution. Any PowerShell will not be used or implemented unless it is remotely signed. So this will help us not to run any unsigned or any malicious PowerShell script. Enable enhanced logging for PowerShell. This is also using some registry keys as we can see here, and then configure some firewall rules. I think you have already uh, uh, configure firewall for outbound. I think delete run rule emergency has already put this to block outside connections. Allow inventory app, restrict PowerShell. Okay, remote IP. Okay, PowerShell. Restrict PowerShell outside or remote IP. Any this to block using PowerShell from outside. Restrict PowerShell ISE. Enable yes remotely any IP. Okay, force password reset for all administrative accounts. So this will be done using get local. So this is local group member, group administrators. These are all the local administrators group, not like domain admin. Okay, not like NT authority. So all of this is the local administrators account, and then set password expire to true. Okay, so this is to make sure that the local administrator has the option of password expire, because it's by default not added or it is not active. Okay, then enable file system auditing for critical directories. Enabling file auditing system for critical directories. Here he will enable audit option on some or certain files. We can do this for certain files. You can enable audit for access for certain files and folders. This can be done through I think if, for example, here let me show you, we can do audit like this. For example, this file maybe, then for properties you can go to security and then advanced. I think you can tell him audit. Okay, auditing, you need to audit this object. Okay, so this is continue. So you need to add auditing. Okay, auditing to this this file. Okay, anyway, so this is also another way. And then so I think we will run all of this on the infected server, which is a very good script, by the way. Let's continue and see what will be what he will do. This is for a malware redemption script. Now let's implement better monitoring to detect similar incidents in the future. If this is it, now we have another security monitoring script. Enter path to server list file. So if you need to monitor a list of servers, and you put the alert email address, and then let's see here, check for after hours login between 8 p.m. and 6 p.m. So this will search for login events after certain time. Okay, this is the script, and it will put it in a CSV file. Okay, and then if there is something, it will be sent, I think, to I think it will be sent to the alert email. Check for unauthorized file changes in protected directories. Let's see here what he will do here. Accessible security 4663, and he will check if there is any changes to any system files. Okay, this is, let me go further here, and this is it. And if we continue, check for scheduled tasks that are also created. Check for new scheduled tasks. Okay, created. This is a good thing. Check for new scheduled tasks, and he will give us any newly scheduled tasks. Okay, so this is it also. Okay, and check for excessive outbound connections. This through also a certain command, and I think he will export them maybe to a temp file, and alert excessive outbound connections detected. Okay, so we can further check for PowerShell script execution also through checking the Windows event logs. Okay, certain events like 4104. Okay, and get the events, and then continue. Then we send an email alert. So a lot of things will be checked, which seems to be good, and I think this is one of the best scripts I have seen anyway. So let's continue with the answer of Mia.
Mia, these scripts are amazing. I see how the command line lets us automate complex security tasks across multiple servers. Victor, nodding. Now let's run our remediation script on app, SRV03. Copy. remediation script.badapp srv03. They watch as the script executes, cleaning up the compromised files, restoring from backup, and implementing enhanced security controls. Mia, what about the other servers? Should we check them too? Victor, absolutely. Let's create a server list and run our security monitoring script against all production servers. Copy. Echo app. srv01 servers.txt echo app. srv02 servers.txt echo app. srv03 servers.txt echo file. srv01
That's the moment, guys.
servers.txt echo file.
So let's continue, guys.
File srv02 servers.txt echo web. srv01 servers.txt echo web. srv02 servers.txt security monitoring.bat servers.txt security-team at company.com. The script runs against all servers, checking for signs of compromise. Scene 7. Virtual lab setup for security monitoring.
So as we see, guys, this is the whole case. I think it is very, very good. And we have used a lot of remote commands, okay, using CMD, and I think he's focusing on CMD, not PowerShell, but I think this is a very, very good case. So with God will, in the upcoming video we will discuss another third case, okay. As we can see here, for example, this is I think this case maybe it is a little bit repeated. This is a sluggish. So let me see if this, no, this is different because, okay, so this is another case concerning a sluggish application server. I think we have discussed a similar case, but I think this is have a different scenario. Anyway, we'll discuss this in the upcoming video. Hope this video informative for you all, and thank you all for viewing. Thank you so much.